Welcome. We're going to do questions 101 and 102, and both of these are very difficult questions. So I'm going to show you my notes on here. Hopefully we can see some improvements on questions like this moving forward. So question number 101, the quality inspector must verify a machine that packages snack foods. The inspector is going to randomly select a package and weigh it. Each is weighed, filling the machine with a standard deviation of 0.03 ounces. So anything from this machine puts that out. So we know that the standard deviation is 0.30, and an estimate of the mean amount of the snack food must be reported within a 99.6% confidence interval, and that the margin of error. So I'm going to look up my formula. I've written this down before. It's a statistic plus or minus the critical value times the standard deviation of the statistic. Okay, so that part, hopefully, we understand. Now, after this, it becomes a lot more difficult because they want to know what is the margin of error. Well, that's this. It's the plus or minus part. So they're deciding to tell me that I need to keep the margin of error no more than 0.07. So this is an Algebra 2 problem. What amount would keep these two numbers, if multiplied, less than the number 0.12? So if I'm going to do that, I have to look on the table of values. And the critical value for 0.99.6, I don't even have. I have 0.995. So I'm already kind of guessing it a little bit. But when I look up on the table, this is my critical value from table B. The critical value for close to this, 99.5, is that. And the standard deviation of the statistic, I know, is 0.30 divided by the square root of n. And that comes right off my formula sheet. Now, this one maybe is slightly different than one we did in the past because it was the proportion question. So the formula for the standard deviation of statistic is different for a proportion than it is a mean question. So ultimately, the fastest way to do these is to plug in my choices. So you can imagine for 8, I could take 2.807 times 0.30 divided by the square root of 8, figure out what I get, do it again, 2.807, 0.30 divided by the square root of 15, figure out what I get, keep going, 2.807, 0.30 divided by the square root of 25, figure out what I get. And I notice by the time I get to 52, now it took me a lot of tries, but by the time I get to 52, when I multiplied this through, I ended up getting 0.11677, which is just under 0.12. So D is my answer, folks. That's probably the easiest way to do this question. You can use algebra working backwards. I'll show you that. Here is my worksheet when I used algebra going backwards. I set up my critical value times the standard deviation, which has to be less than 0.12. I plugged in these same values. I cross multiplied to solve. So I squared both sides. I got n by himself. I end up getting 49, which is pretty darn close. But remember, I kind of guesstimated this number. So I actually plugged 52 back in, and now I feel pretty confident that's my answer. Next question. 101 gives us a cumulative relative frequency graph. These are difficult. We talk about them way back in August, and then we don't talk about them again. So I'm going to give you some basics. The basics on what this is and how it works and why it works is that this is telling you the frequency. It is not actually the data value. So this isn't the number of data that came in for that. It's the frequency. cumulatively. So that's why the last number in a cumulative graph is always 100, or the most, or the last value, or the max. And this is your min. So your min looks somewhere around maybe 33, and your max looks at 100, okay? Now, do you see this shape here? It looks like kind of a fancy S. That's what a cumulative frequency graph looks like when the data is normal. So just looking at this nice, beautiful S, I know the data is normal. And you think of this as like the rate of information coming in. The data came in slowly, just a little bit at a time. Eventually I got more information, more information. Here's where the median would be. And then I get more information, you see it tapering off. That's what a normal graph looks like. Not a lot of info, a little bit more, a whole lot, a little bit less, not any at all. This is what a normal distribution looks like. This is what the graph looks like if you put it in there cumulatively. So this is a graph, a cheater graph that helps you make a box plot. When you see 50, you immediately know the median is somewhere between, I don't know, I'm guessing around 75 or so here. I can very quickly find Q1 data. So this is my median. Pretty quickly, I can find Q2, excuse me, is the median. I can quickly find Q3. So off of this graph, it's really handy to find a box plot, an IQR, that type of information. It's not handy if you think it's an actual histogram, which it is not. So let me explain what this is. It's everything less than that because of this idea cumulative. So the reason why this bar is all the way up here is that by the time you get to 100, all of the tests have been put in. So 100% of the tests got the score of 100 or less. Here at the median, 50% of the students got a score of, let's say, 75 or less. Here, what does this mean? It means not a lot. Less than 25% got the score of 50 or less. In fact, it looks like right around 70. The bottom 25% of class, Q1, the bottom 25% of class got the score of 70 or less. So that's what this graph is doing. So when I look at these, it says there is greater variability in the lower 20 scores. They're not saying 20% of scores, just the lower 20 scores. So let's look at this. It says this is a graph of 40 scores. So they're talking about the lower half. Okay. So in the bottom half, so it looks like, as I said, the median appears to be around, I don't know, maybe 75, maybe a little more than that. And the lowest score looks 33. So the variability of the lower half of the students is 42. Now let's look at the upper half. Well, the upper half, the scores range from 100 down to 75. So that's 25. So it does appear that there's a greater level of variability in the lower half than in the upper half. I'm going to pick A. Now, that's the right answer. Now, let's look to see what other information, because these should all be false. The median test is less than 50. No. We just said the median, I call this a cheater graph, because I can immediately scan over and find where the median is, and it should be somewhere between 70 and 80. So I've disproved this. 60% of the students had test scores above 80. Okay, so I'm looking here. It appears at the score of 80, and I scoot over, it appears that maybe about 60%. They wrote 60%, but this is a cumulative frequency graph. So the fact that 80 goes up to 60 means 60% of the students scored 80 or below, not, this would be the word below. So that can't be true. D states if the passing score is 70, most students didn't pass. Hold on a minute. The median score is 75. So you already know that more than half, or exactly half, got a score of 75 or more. So of course, it looks here by 70. In fact, 75% of people scored above a 70, because quarter one, 70, the lower quarter scored 70 or less. So again, each of these is reading a graph. The passing score of 70, most students did pass. Only the lower 25% of people looked like they were in risk of not passing. All right, now let's look at E. The horizontal nature of the graph for test scores of 60 and below indicate those scores occurred most frequently. That's the opposite. Again, this is the frequency graph. That's what this is how frequent did it happen? So notice very few numbers, infrequent, 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 more frequency. The horizontal nature here is showing you, just like a normal graph, very few or low frequency, low amounts here at the beginning. So this one is definitely discounted. Thanks for joining us.